MORGEN, der Podcast des Fraunhofer IESE. Engineering the Digital Future.
So hello everyone, I'm Pablo Antonino. I'm the head of the Virtual Engineering Department here at Fraunhofer IESE in Kaiserslautern, Germany. And today I'm thrilled to be joined by Dr. Alex Foessel from Balance Engineering. And we will be discussing our exciting collaboration on virtual engineering, digital twins, and simulations, specifically in the context of precision and intelligent off-road vehicles, with a focus on agricultural equipments. Alex, thanks for joining me.
Hey, Pablo, this is very good. I'm happy to talk to you.
Excellent. Can you say a few words about yourself so our audience can get to know a little better?
Sure. So maybe first and foremost, I am a rancher myself. So have a ranch in Chilean Patagonia. That is where I grew up. But going further, I had an opportunity to study electrical engineering, and eventually I got a PhD in robotics at Carnegie Mellon University in Pittsburgh, Pennsylvania. I work for John Deere, working in automation and robotics for 19 years, actually. And I had the opportunity to not only work in the U.S., but also I spent 3 years in Germany, in Cologne, and also 5 years in Brazil. In all of these cases, looking into how to integrate autonomy and advanced technology into production system, agricultural and construction production systems. Today, I run with my partner, Rick Wires. Balanced Engineering is a consulting and engineering services firm that is working both with OEM and startups in helping them develop more advanced robotic solutions for ag and construction, but also working with large ag producers to help them adopt these technologies in their production.
Thank you so much for all these details. So what I hear is that we'll be able to listen from you, not only like a management and business-oriented experience, but also like how these technologies can help people on their daily lives, people that are really working in the field, the machine operators, and so on and so forth. And this is very exciting. So let us start, Alex, talking about virtual engineering in agriculture. So virtual engineering and digital twins, they are really at the heart of our collaboration, Fraunhofer IESE and Balance Engineering. And looking back, what originally inspired Balance Engineering to embrace virtual engineering, digital twins for off-road machines, specifically for agriculture?
Well, actually, I could even trace it back to some of our earlier conversations with you, Pablo. But in summary, when we look into the complexity of systems that have a lot of software, now they have machine learning components, and they have to interact with highly complex areas, such as an agricultural field that is changing over the seasons, where the crop grow, etc. You have a very large number of dimensions of testing, of developing, etc. My point is that you're developing complex machines to work in complex environments, and there's no possibility of testing in reality all of the dimensions of design. So then, for a company that is engineering an agricultural robot, to be able to say that the system works for all of the conditions, you can't do that in real life because it would be years and years of testing. And plus, you can't always even control of the test variables because you're going to have weather, you're going to have plants growing, you're going to have possibly livestock. So digital engineering and virtual engineering are fundamentally necessary to advance technology, autonomy, and robotics into agriculture.
Thank you so much. That sounds really exciting. And can you walk us through an example on how we have used digital twins and simulations as examples of virtual engineering technologies to address specific challenges in agriculture or off-road vehicles in general? Something that we did in our collaboration, that we're doing, or that you see, that you anticipate, really a concrete example that our listeners would understand the instantiation of those technologies for the domain?
Yes, of course. And I'm going to go back to the ongoing work to create a digital version of multiple machines running in a field that is producing, for example, some type of grains, right? Here we have a simulation that is based on Fraunhofer's technology that is able to simulate the environment, the weather, the lighting conditions. And that, Pablo, is very important because now we can put different designs to work in those conditions. So let me give you an example. With a simulation that includes varying light conditions, now we can test multiple sets of cameras. We can use the camera models and understand as to whether they have the capability of, for example, finding a person to make sure that the operation of this ag robot is going to be safe. If we consider also the inclusion of weather phenomena, for example, rain or snow or mist, well, all of those are conditions, and we can actually see whether the selection of sensors is adequate, whether the sensors have the right sensitivity, and that we can guarantee, and I'm going to think of one very important part of the design, which is safety. We can test and guarantee as to whether the collection of sensors that this machine is going to use will indeed be safe enough to detect people, pedestrians, animals, or other pieces of equipment to avoid any collision.
This is great. And with all these radars and leaders, and as you said, different cameras in place, so we can really combine these different inputs with our technologies to increase the safety, not only of the individuals that are walking in the field, of the operator, of course, but we cannot ignore, Alex, the fact that we have also economical implications, right? Whenever one equipment that is not a cheap one, like a big tractor, is involved in some kind of accident that could be avoided by this kind of analysis that we conduct with our technologies, that has also a business implication for the farmer, for the machine producers, and so on and so forth. With that said, could you give us like a little bit more of business perspective, like KPIs that the business would profit from by instantiating and using these technologies?
So let me answer this question two ways, because to avoid mixing the value that the simulation is going to create to different types of companies.
Sounds good.
On one hand, you have the OEMs, and I'm talking of the very well-known brands of agricultural equipment, Case New Holland, AGCO, Fendt, as part of AGCO, John Deere, and a large number of other companies that are creating more and more automated pieces of equipment. The virtual engineering for them brings a number of key business advantages. First of all is the speed to market. When you have a virtual engineering set platform with a simulation of the crops and the conditions where these machines might work, you can actually go through a very large number of architectures or configurations and test them, virtually, and quickly come to a conclusion or a very likely design that is going to meet functional requirements, safety requirements. It will meet the limitations of design, and eventually even meet the business requirements for that particular design. In other words, you can test so many different configurations that you can get to one that seems to be the most likely to meet all of these requirements faster. Pablo, that is real money. That is a real money that the company is going to save, because you don't need to invest on a multi-year long engineering effort. But in addition to that, you can have the possibility of getting to market faster and be seen as the innovator, as the one who brings the most productive and safe solutions to the market first. That is as it relates to the OEM. Now, when we look at the benefit for a grower, especially for these large growers, and you and I were chatting about some very large Brazilian growers prior to us starting the program, well, they have to deal with the following. They have a complex system with a very large number of machines, with changing conditions, and using virtual engineering and specifically digital twins allows you to say, well, how many machines do I deploy? Where do I deploy them first? How do I coordinate them? And that allows the companies to actually stage their assets so they can actually work better doing the, let's say, harvesting tasks or application tasks or soil preparation tasks. So then you can optimize the use of your assets. And then that leads to more yield, less input cost, maybe less asset intensity, and that goes directly to the bottom line of these large producers that become more profitable.
This is so great to hear, Alex, this different perspective, because here we are talking, as you said, we have the engineering aspect of the OEMs, and we also listen the aspect, as you said, of the grower, right, of the farmer. And I think that your experience on both sides of this coin helps us to really understand that. And I'm so glad that you're sharing all this. We hear a lot about this benefits in other domains, right? Like for the automotive sector, the traditional vehicles, or production plants for medical devices. But it seems that for the ag, we are doing something innovative here, some kind of innovation, really deploying these virtual engineering technologies, more specifically digital twins and simulations, to enable these technical and business drivers that you mentioned. And I believe that this joint work of Balance Engineering and Fraunhofer IESE, it's really important because we bring different strengths, different expertises, and we combine them, right? So in your view, how does this partnership, Balance Engineering, Fraunhofer IESE, enhance our ability to innovate in this domain?
Pablo, I think that we are very, very complementary. And then let me give you a couple of examples. So you bring the platforms, the technology, the knowledge of having created virtual engineering platforms and digital twins in multiple industries. And actually, you just mentioned one that caught my attention when you say about industrial automation and production plants. Well, I just want to leave our listeners with the following analogy. Really, to grow food, whether it's grains or whether it's wood for sheltering, or cotton for fiber, or even sugarcane for energy, growing living things is kind of like a industrial process. It is a manufacturing process, except that it has no roof. It is exposed to the weather, etc. But fundamentally, you have a series of steps, jobs that you need to do until the crop grows and you can harvest it. Well, going back to the value of the partnership, Pablo, because you have developed these digital twins and virtual engineering platforms in other industries, you bring all of that powerful simulation capability. And where we can help is to bring the specifics of how plants grow, of how terrains are plowed by farmers. We can also bring more insights into what are the money aspect or the financial aspects of growing food. And then by matching those two, we can offer these tools and platforms to OEMs building agricultural machines, and also to growers that are looking to enhance and optimize their operation. That's why I think that you're bringing really good, proven models and insights and knowledge of virtual engineering, and we can bring the actual industry domain knowledge that enables those to work together.
This is so true, Alex, and I perceive the excitement of our engineers that are developing the solutions, enhancing the solutions that we're working on together with Balance. That this is really tangible. When we talk to you, it's like we have this really feeling that we're talking with people that understand the business. This is not like a trial. So we're really developing things that there is a clear market demand and that we position in the market. And as you said, we'll have a clear impact, not only for the moment that the ag operations are happening in the field, not only for the companies or for the different stakeholders at the business level, But there is also another aspect that we have been discussing, Alex, that has to do with sustainability, right? So we are talking about this all over the place. We talk about electrical vehicles. So we talk about hydrogen-powered vehicles these days a lot. And this is something that I also would like to get with you. So what is your perspective regarding sustainability in regards to these technologies that we're developing centered on virtual engineering? What's the impact on sustainability that we're bringing here?
Sustainability, especially in agriculture, has a number of dimensions. And you mentioned a few that have to do with electrical vehicles and maybe burning less fuel, perhaps, and a number of other things that may lead to, let's say, less carbon emissions. But also in the case of agriculture, there are two other areas of sustainability that I would like to mention that can be enhanced and improved using virtual engineering. The first one has to do with the reducing the application of chemicals. When we use virtual engineering to create machines with the sensors to actually detect disease and apply only where that disease exists, we are moving away from these more traditional practices where you apply chemicals to every plant. So now you can develop robots that can apply chemicals to only those plants that have disease. So this is one aspect of sustainability that has to do with just applying less chemicals to nature. And that means that those chemicals are not going to run into rivers, possibly pollute natural ecosystems, etc. So I think that I'm very proud of the work that we're doing because it also is going to enable that aspect of sustainability. The second aspect of sustainability that may not be as closely understood by people has to do with emerging regenerative farming practices, where you look for biological diversity. So you're not just planting one crop leading to, thousands of hectares of a monoculture, but instead to try to bring forestry, livestock, agriculture crops together and start creating ecosystems that have the diversity and where different plants help others and where the soil becomes much more biodiverse and healthy. Well, all of these practices are more complex agricultural practices. And then the execution of them is very difficult to do by just operators and people. But when you bring automated equipment, and also when you bring the ability to simulate all of these living organisms growing together, then you can actually bring to market and actually execute very sustainable farming practices, because now the machines know exactly what they need to do and when to do it to enable this regenerative farming practices. So yes, everything is, the virtual engineering is going to help things such as, modern drivetrains that are going to be more electric with less fuel. But in agriculture, we have these other two elements of sustainability. And again, I think that these are being enabled by the benefits of virtual engineering.
This is so inspiring. And I look forward each day more for the things that we're doing together and the impact that we are somehow leading to, not only, as I said, to our customers, but as we're talking now, we're talking of the impact of this technology for the society.
Mm-hmm, absolutely.
Right? And this is for the healthy of the individuals, right? So we started talking about engineering and now we move to sustainability and we're talking about the impacts for the society. So how do you think that these technologies will influence the future of agriculture on a global scale?
I think that there are many people who feel inspired by working in agriculture and creating machines that are going to make the work, the life of farmers easier. Farmers work a lot. From very early to very late, and they are there when the farm requires them, 365 days. So by bringing these highly automated machines and eventually robots, we're bringing back, and this may be a part of the previous question, right? We're bringing back sustainability from a family perspective, from a life quality perspective. But going back to your question about the global impact, when we have only physical engineering, the more traditional one that requires to be testing things in the fields, we restrict the innovation to those crops that are nearby ourselves. So you in Germany, you're going to be looking into the crops that you grow nearby, and you're going to develop machines for those crops. But it's very unlikely that you're going to be using your innovation capabilities to design the most automated and capable machines for, let's say, tropical agriculture. I'm going to use Brazil as one example, where the crops are different. So you have sugarcane and others. You don't have sugarcane nearby in Kaiserslautern. So how could you, and I'm going to use in this case Fraunhofer IESE, how would the highly capable engineers of Fraunhofer IESE be able to design capable machines for Brazil when those crops are not close to you? And by having digital twins that are showing how cane grows and what are the particular aspects of that production system, now your team can be working in helping farmers down in Brazil grow sugarcane with robots. So that is one example. We're making this very large Earth of ours, I don't know that smaller, but more connected. And now we can have all of this talent that is globally available to work on really interesting problems, the problems that affect sustainability of society.
This sounds so exciting. So you are a man that travels a lot. So I understand that right now you are in Chile while we are recording this podcast, but Balance Engineering and your base are in Pittsburgh, right, in the United States. And I understand that you'll also be soon in Europe working with our customers and potential customers. And what is to come is this world-renowned exposition, the Embedded World 2025, where we are going together to present the results of what we're doing regarding the use of virtual engineering, digital twins, and simulations for ag, right, together with you guys. So, and this is something that we're really excited to get together in the Embedded World in Nuremberg. And what message would you like to share with our audience, especially those who will see our work at the Embedded World 2025?
Well, first of all, come and talk to us. Every collaboration, every business, everything starts with having a conversation. So come to the booth and let's have a conversation about how virtual engineering has been very successful in impacting agri industries. But now the time has come for virtual engineering and the related digital twins to start impacting one of the most complex areas of work, which is smart machines off-road around living things. And we need to have a conversation because the value proposition of these tools and systems may be different. And we want to learn from you. And that's why it's important that you come visit us. We have a conversation. We show you what we got and what we would like to learn from your specific requirements and how we can extract value to this investment.
Thank you so much, Alex, for your time. I would like to finalize by my side, thanking you for your time and for sharing your knowledge and excitement with us. And I would like to leave these final words for you. If you would like to leave any closing message to our listeners.
Working to grow food, it is always a very rewarding activity. Helping farmers do their job easier is a very rewarding activity. And working together with professionals, in this case, like you, Pablo, and your team, is a very rewarding activity. Life is really good.
Thank you, Alex. Thanks for the listeners. Bye-bye.
Bye-bye. Thank you.
MORGEN DENKER. Engineering the Digital Future.